Hi everyone, the topic of this video is factoring out common monomials from polynomials. Factoring is the opposite of what we have been doing. So factoring is the opposite of multiplying. We were multiplying to get a product. Now we are going to factor to get two terms. So to factor a number or polynomial means to write it as a product. For this part, and there's many different ways to factor, but today we're going to focus on finding the greatest common factor. Just like if you had a fraction and you needed to reduce it, you would find the number that goes into that denominator. That's what you're doing here, finding the greatest common factor. So if you had 12 and 24, what is the greatest number that goes into both of them? That would be 12. If you have variable terms, you have to think about the greatest common factor that is a number and the greatest common factor that is the variable. So between 2 and 4, the greatest number that goes into both is 2. And x squared, the greatest variable would be x. It can't be x squared because this one doesn't have an x squared, it just has an x. And x squared, again, is just x. One way that you can see this is to write it out as a set of factors. So 2 times x, and 4x would be 2 times x times x. They each have a 2, and they each have an x. So again, when we were multiplying, we took and multiplied over the parentheses using the distributive property. So 6 times x is 6x, 6 times y is 6y. We can use the distributive property and work backwards to find the factors. If you look at both of these, what do they have in common? They have a 6. So if you divide out or factor out a 6, you're left with, so if you take a 6 out of this term, you're left with x. If you take a 6 out of this term, you're left with y. The other way I think about it is 6 times what would give me 6x, and 6 times what would give me 6y. So let's practice with some of it done for us. Here is my original where it's already multiplied, and I want to pull the factors out. So I look at my numbers. What do they have in common? They have a 3. So if I factor out or divide out a 3 from 6x, I'm left with 2x. If I divide out a 3 from 9, I'm left with 3. Or I could think 3 times what number gives me 9. Alright, so here it is already multiplied out, and I want to see if I can write it as a set of factors. So I want to see what they have in common. Each term does not have an x or a variable, so I know that a variable is not part of what I'm going to divide or factor out. If I look at the numbers though, 15, 20, and 35, the greatest number that goes into all of them is 5. So that means I can divide out or factor out a 5. So 5 times 3x squared gives me 15x squared. If I divide out a 5 from 20x, 20 divided by 5 is 4, so 4x. And then 35 divided by 5 is 7. So as I said, there are many different types of factoring. This first factoring is just factoring out a common monomial, and we'll practice that today. The steps: first find the greatest common factor in the coefficients. Look at the numbers. So if I have 3x squared and 6x, I'm going to look at my numbers, and I know that I can factor out the greatest number they both have in common is 3. Then I'm going to look at the variables, x squared and x. Again, if I had an x times an x, which is x squared, and an x, they have one x in common, so I can factor out an x. So then I'm going to divide or factor the common monomial to write the expression as a product. So if I divide 3x squared by x, this goes back, and I'm going to write it over here, this goes back to our division rules of exponents. That cancels. X squared divided by x is just x. The other way I could think about it is 3x times what gives me 3x squared. 6x divided by 3x, The x is canceled. 6 divided by 3 is 2. Or I can think 3x times what gives me 6x, and it is 2. So this is my final answer. We will not go back and multiply it out because that would give us our original problem. So this is it. So you're going to look at the coefficients, the variables, and then you're going to divide. And you need to make sure you can factor out of all expressions. So here, if I look at my numbers 7 and 21, they have a 7 in common. 21 and 3 have a 3 in common, but 7 and 3 don't have anything in common. So we can't factor out a number. Here I have x to the third and x squared, so it looks like I can factor out an x squared, but the 3 does not have a variable term, so there isn't anything that all of the terms have in common. So we can say that this is prime from what we know, or we need to just leave it as is. So let's do some practice problems. For this first one, I'm going to look at the numbers first. 2, 4, and 6. The greatest number that can go into all of them is 2. Then I'm going to look at my variables, y to the third, y squared, and y. They have a y in common. So if I divide 2y to the third by 2y, I'm left with y squared. If you need to write it out like this from our exponents unit, please do. So the 2's cancel, y to the third divided by y leaves y squared, or you can think 2y times what gives me 2y to the third. Alright, so then we'll do the next term. 2y times what gives me 4y squared? Well, 2 times 2 is 4, and y times y is y squared. Again, if you want to write it out, let me try that again. 4y squared divided by 2y. You can do that. 4 divided by 2 is 2, y squared divided by y is y. And then the last one, 2y times 3 gives me 6y. So this is my answer. I factored out a common monomial, so now it is in factored form with 2 factors. Alright, first I'm going to look at my numbers for this second example, 6 and 5. They do not have a number besides 1 that can go into both of them. X and Y are not, they don't have anything in common either, so we would say that this is prime because we can't factor it. And then the last one, 4, 8, and 16. The greatest number that goes into all of them is 4. X to the fourth, x to the third, x squared. The greatest that goes into each of them is x squared. And I'll write this out so you can see it. X times x times x times x is x to the fourth. X times x times x is x to the third. And x times x is x squared. They have 2 in common. So that's the greatest number of x's I can pull out. Alright, 4x squared times what gives me 4x to the fourth? Please write it out like this if you need to. C. The 4's cancel. X to the fourth divided by x squared. Remember, if you're dividing exponents with the same base, you subtract the exponents. So that would be x squared. This is minus, so it's going to be minus. What 4x squared times what gives me 8x to the third? Well, 4 times 2 gives me 8. X squared times x gives me x to the third. Minus 4 times 4 gives me 16. X squared times, we don't need any other x's because it is x squared, so that's it, just 4. So, again, this is what I'm looking for. This is what your final answer should look like. You're not going back and re-multiplying it all back out. You're leaving it like this. So to review, you're looking for the greatest number and greatest variable they both have in common, and then you're dividing it out of each term to see what you have left for the other factor.